In this video, we'll be identifying the center and radius of a circle when its equation is written in general form. So what is general form? The general form of the equation of a circle is x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are real numbers with a radius of r and a center hk. Basically, what that means is your standard form has been multiplied out. There won't be any parentheses. You're going to have a quadratic and a linear term for x or y, or possibly both. This form of a circle says that the radius is r and the center is hk, but if you look at that form, those variables are not listed. A circle must be in standard form to identify the center and the radius. So what we're going to have to do is transform our equations from general form into standard form, and the way that we're going to do that is by completing the square. So let's identify the center and radius of the equation x squared plus y squared plus 2x plus 4y minus 9 equals 0. Notice that there is a quadratic term for both x and y, x squared and y squared, and then a linear term as well, the 2x and the 4y. Since there is a linear term for each variable x and y, this tells us we're actually going to have to complete the square 2 times, once for the x and once for the y. If you feel you need a refresher on completing the square, be sure to check out my other video that very slowly goes through the process of completing the square. First thing I'm going to do is I'm going to get organized. I'm going to group my x terms together, leave a space, group my y terms together, leave a space, and then move the constant term to the right side of the equation. We'll have x squared plus 2x, and then I'm going to leave a space, plus y squared plus 4y, leave another space, and then I'll add 9 to both sides so that my constant is on the right side of my equation. Now we're ready to start completing the square. I'm going to start completing the square for the x's. To create a perfect square trinomial, we need to add b divided by 2 squared to those two terms. So we'll take our b value of 2, divide it by 2, and square it. So that's going to be 1 squared, which is 1. So I'll add 1 here to make a perfect square trinomial, but I know I have to add 1 to the other side of my equation as well to keep it legal. This perfect square trinomial always factors into the form x plus b divided by 2 quantity squared. Our b divided by 2, that's always the number you have in the parentheses right before you square it. So this factors into x plus 1 quantity squared. And now we'll move on and complete the square for the y's. I'm going to take its b value, which is 4, divide it by 2, and square it. So that's going to be 2 squared, which is 4. We add 4 to both sides. We have created a perfect square trinomial on the left that factors into the form y plus b over 2 quantity squared. Again, our b over 2 is the number we had in the parentheses right before we squared it. This trinomial factors into y plus 2 quantity squared. And then I'm just going to add up the constants on the right. We get 14. We have transformed our equation from general form into standard form, and now we can identify our center and radius. Remember, going from the equation to the center, it's always the opposite sign that we see. So I see a +1 and a +2. That tells me my center is going to be -1, -2. And the radius is always the square root of the constant. So our radius is the square root of 14. We try to simplify the square root of 14. We can't. So there we are. Center of -1, -2, radius square root of 14. Let's try another. Let's identify the center and radius of 3x squared plus 3y squared minus 6x minus 7 equals 0. Well, there's a couple things I notice about this equation right away when I look at it. First off, I notice that there is no linear term for y. There's only a linear term for x. That tells me that I'm only going to have to complete the square one time for the x's, and I'm not going to have to do anything for the y. So I'm going to rewrite it in order, get my x terms together, my y term, and then add 7 to both sides so that my constant is on the right. Well, now I need to complete the square. Completing the square can only be done when the leading coefficient, the coefficient on the quadratic term, is equal to 1. And you'll notice that the coefficient on x squared is 3. What we're going to have to do is divide each term by 3. That gives us x squared minus 2x plus y squared equals 7/3. There will never be a time when you are working with circles that the coefficient of the x squared and the y squared aren't the same. So even if we had an example where we had to complete the square for both x and y, the coefficient on the two quadratic terms has to be the same. If it's not a circle, it's an oval. And we'll talk about that another day. Okay, let's complete the square for the x. I'm going to take its b value, divide it by 2, and square it. That'll be -1 squared, which is 1. Adding 1 to both sides. We've created a perfect square trinomial on the left that always factors into x plus b divided by 2 squared. Our b divided by 2 value, is the number we have in the parentheses right before we square it. So this factors into x minus 1 squared plus y squared equals, adding 7/3 plus 1, we get 10/3. We've transformed our equation from general form into standard form. We can now identify the center and radius. Going from the equation to the center, we know we want opposite signs. So the x-coordinate of the center is going to be +1. And since y squared is all by itself, that tells us the y-coordinate of the center is 0. So we have a center of 1, 0. The radius is always the square root of the constant. We'll have the square root of 10/3. We want to simplify our radical. Now, when you have the square root of a fraction, you always want to break that up into the square root of the numerator over the square root of the denominator. Neither of these are perfects, but I don't want to leave that square root in the denominator, so we actually need to rationalize this. We'll multiply the numerator and the denominator by the square root of 3. This gives us the square root of 30 over the square root of 9, which is 3. We try to simplify the square root of 30, but there's no perfect square that's a factor of 30. So our radius is the square root of 30 over 3.